Assalamualaikum warahmatullahi wabarakatuh and very good morning. In this video, we are going to explain 10 questions related to matrix and matrix operations, also related to solving system or linear equation by using elementary row operations. We are going to divide this video into two parts and discussing for part 1 from question number 1 to question number 5 only. For part 2, continue with question number 6 up to question number 10. Okay, all questions are related to finding the value of k with certain condition given. For example, question number 1, find the value of k if matrix A is invertible. Now, we have to understand what we mean by this word invertible. Mean matrix A have inverse. Matrix A have inverse. What that word means? Okay. Therefore, the determinant of A must not equal to 0. Thus, we can find the determinant of A, that is k times k. We have k square minus 2k times 1 is 2k, must not equal to 0. Now let's solve this. We can factorize k, right? K multiplied by k minus 2 must not equal to 0. Okay, therefore we have k must not equal to 0, and the other one, k must not equal to 2. Okay, in order for this matrix A to be invertible, meaning have inverse, k must not equal to 0 and k must not equal to 2. Other values, for example, if we choose k equal to 1, for example, yes, the value of k equal to 1 will make matrix A invertible, meaning have inverse. Other values like k equal to negative 2, this value of k also will make matrix A invertible, meaning have inverse. Now, only these two values, that is k equal to 0 and k equal to 2, will make this matrix having no inverse. Okay, if we choose k equal to 0 and k equal to 2, will make matrix A singular, meaning have no inverse. For other values, yes, matrix A will be invertible, meaning have inverse. I hope you understand what I mean. Now, for question number 2, this time we want to find the value of k, if matrix B is singular. Oh yes, now this time we are given a 3 by 3 matrix. Okay, having 3 rows and 3 columns. And mention here that matrix B is singular, meaning no inverse. Okay, singular means no inverse. Now, how about the determinant? Yes, the determinant of B must equal to 0. Alright, so now let's try to find what is the determinant of matrix B. We can use arrow method, that is, we write down the element of the matrix 2k2, we have 1 2 1 2 2k, and we have to add row number 1, that is 2k2, and column number 1 and column number 2, 1 to 1. Now the first arrow is going downwards like this, second arrow is this one, and the third arrow going down like that. So the determinant of B equal to 2 times 2 times k is 4k, plus we have 4 and we have 2k, and minus arrow going up like this, first one, second one, and this is the third one. 2 times 2 times 2 is 8, 2 times 2 is 4, and k times k plus k square. Okay, this value must equal to 0. Alright, so now we have 6k plus 4 minus 12 minus k square equal to 0. We have 6k minus 8 minus k square equal to 0. Multiply by negative 1 and rearrange the the terms. We have k square minus minus 6k plus 8 equal to 0. Factorize, we have k minus 4 and k minus 2 equal to 0. Therefore, we have k equal to 4 and the other one k equal to 2. Two values for k, that is k equal to 4 and k equal to 2, will make this matrix A singular. That is no inverse for matrix B. Okay, what is the value for k again? 2 and 2 and 4. The value of k 2, the value of k equal to 4, these two values, k equal to 2 and k equal to 4, will make matrix B singular. Okay, that's question number 2. Question number 3, related to matrix multiplication of 2 by 2 matrix on the left hand side and given the answer on the right hand side. But on the left hand side, we have the unknown k over here. So we want to find what is the value for k. So what we have to do is we can multiply the terms or the matrix on the left hand side. 2 by 2 times 2 by 2, we are going to have 2 by 2 matrix also. Negative 1 times 1, and then the other one is 0, so we have negative 1 over here. Over here, negative 4 and 5k, so we have 5k minus 4 over there. This one is 2 plus 0 is we have 2. 8 plus 15, we have 23. This is equal to, given on the right, we have negative 1, we have 2, we have 2 over here also, we have 23. Now let's compare these two matrices on the left and on the right hand side. Therefore, if we compare position wise, okay, position here is position 1, 2, this is position 1, 2 also. Therefore, we have an equation, right? That is 5k minus 4 must equal to 2. Thus, 5k equal to 4 plus 2 is 6, and k equal to 6 over 5. Okay, that's the answer for k. Alright, done with question number 3. Continue, question number 4. Yeah, here it is. Question number 4. Find the value of k if the system of linear equation have no solution. Okay, have no solution. Now, in order for us to know that the question is having no solution, what we have to do? We have to do elementary row operation on our augmented matrix. That is, we have to write down the coefficient matrix, that is 1. We have k, we have k, we have 1, and we have 1, 1 on the right hand side, like this. Okay, now let's do elementary row operation on this matrix. Now the first part is that we have to make this number k, we have to make it 0. Okay, if we want to get that, so what's operation that we have to do is k multiplied by row number 1 minus row number 2, and write the answer in row number 2. Okay, row number 1 is still the same. We have 1, k, and 1. This number will be 0 because k minus k. K times k is k square minus 1. We have k square minus 1 over here. Over there we have k times 1 is k, k minus 1. K minus 1. This is the partition. Alright, that's what we have so far. Okay, since we want to have the system have no solution, okay, this component here, this component must equal to 0, but this component must not equal to 0. Okay, that's the condition to be, okay, to have no solution. Okay, we have to have a contradiction, remember? So k square minus 1 must equal to 0. Therefore, from here we have k square equal to 1. Okay, take square root both sides, we have k equal to 1 and also negative 1. Now, for this part, we have k minus 1, okay, not equal to 0, and k must not equal to 1. We cannot accept 1. Alright, therefore, here, this one is not acceptable. Okay, we only accept negative 1. So there we have it. We already have the answer. That is, for this system, this is our system of SLE, system of linear equation. To have no solution, k, okay, according to our calculation, k must equal to, here it is, must equal to negative 1. Must equal to negative 1 only. One answer only. Now let's continue with question number 5. Find the value of k if rank of A is equal to 2. That's the information given to us. The rank of this matrix A is equal to 2. So in order for us to solve the value for k for this problem, we have to use elementary row operation until we have the matrix in the form of a row echelon form. Okay, in the form of row echelon form. Okay, so now what we have to do is we want to use elementary row operation. Elementary row operation. Okay, we discussed that in class already. So we have 1, 2, and 2k. We have 1, we have 3, and k. We have 2, we have 6, and 1. Okay, this is the original matrix that we have. So in order for us to have REF, this number 1 must be make into 0. Number 2 also we have to make it 0. So let's do 2 operations simultaneously. For number 1, for row number 2, okay, let's do this one. R2 minus R1, and let's write down the answer in row number 2. For row number 3, to make that number 2 become 0, let's do this. 2 times row 1, 2 times row 1, and then we subtract row 3 and write the answer in row number 3. Okay, that's our plan. That's our calculation. So for row number 1 is still the same. We have 1, we have 2, and we have 2k. For row number 2, 1 minus 1 is 0. 3 minus 2 is 1, and k minus 2k is negative k. Okay, now for row number 3, it's become 2 minus 2 is 0. 4. Alright, 4 minus 6 is negative 2. 4 minus 6 is negative 2. And 2 times 2k is 4k. We have 4k minus 1 there. 4k minus 1. Alright, now is this already in REF yet? No, it's not yet. No, so we have to continue the process. Let's continue. Okay, we want to make this number negative 2. We have to change it to 0. Okay, so the operation that we have to do is this one. That is 2 times row 2, and then we add it to row number 3 and write down the answer in row number 3 and see what happened. Row number 1 is still the same row, 1, 2 and 2k. Row number 2 is still the same also. We have 0, we have 1, we have negative k. Now this is 0 there. 2 minus 2 is 0. Now let's do this operation. 2 times negative k, and then we add with 4k minus 1. Let's simplify this. Negative 2k plus 4k minus 1. This is equal to 2k minus 1. So we have here 2k minus 1 like that. Now let's ask ourselves, is this matrix already in REF? The answer is yes. Okay. Now we are ready to write down the equation, because we are given in this problem that this matrix A having rank A, rank equal to 2, meaning the number of non-zero row when it is in REF must be 2 non-zero row only. Meaning to say this last row must be a 0 row. Okay, that's what the rank of a matrix means. The number of non-zero row when it is in REF form. So since this is given matrix A having rank equal to 2, so we have to have only 2 0 row, meaning the last row here must be equal to 0. So we already have 0 here. Very good. This 0 also we already have. Now this component here also must be equal to 0 in order for us to have 0 row at the third row. So we have an equation there, right? So we have 2k minus 1 must be equal to 0. Therefore, 2k equal to 1 and k equal to 1 over 2. Okay, there we have it. K equal to 1 over 2. Okay, in order for this matrix A, to have rank equal to 2. Okay, I hope you understand what we call the procedure, the process, how we get the value for k that is equal to 1 over 2 for this question number 5. Okay, that's all for now. See you next time. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.